The viability and safety of nuclear energy is a topic being discussed fervently through media outlets such as television and newspapers, due to the recent disaster in Fukushima, Japan. There are strong reasons being pushed for the continued campaigns for or against nuclear energy. In this short presentation, I'll be showing both sides of the argument and providing evidence for either side. Context. Nuclear power stations are similar to fossil fuel and hydroelectric power stations in that both generate electricity via turbines, which convert kinetic energy into electrical energy. Uranium was discovered in 1789 by a German chemist Martin Klaproth. It was named after the planet Uranus. Pierre and Marie Curie gave the name radioactivity to ionizing radiation. In 1902, Ernest Rutherford showed that radioactivity was a randomly occurring event which emitted an alpha or beta particle from the nucleus and created a different element. Nuclear fission was discovered at the end of 1938 by Niels Bohr and his colleagues. They proved that a neutron could be captured by a uranium nucleus, which led to the nucleus splitting into two almost equal parts, barium and krypton. This was confirmed irrefutably in 1939 by Otto Frisch. The first electricity generated by a nuclear reactor was at the ERB-1 experimental station in 1951. Soon after, the USSR's Obninsk nuclear power plant became the first nuclear power station to supply electricity for a power grid in 1954. Now that we have an idea of the origins of nuclear power, we can look at each side of the nuclear power argument and determine which one is more beneficial to society. To begin, we look at the safety of nuclear energy in the world. Many people wrongly believe that nuclear power plants are ticking time bombs ready to melt down at any moment. This, of course, is hugely false. The accidents which have happened were either completely unprecedented circumstances, such as Fukushima, or plant operator error caused by inadequate training and overcomplicated machinery, such as 3 Mile Island and Chernobyl. It is falsely believed that there have been catastrophic losses of life because of these accidents, the worst being Chernobyl, which caused the evacuation of 135,000 people and the immediate death of 31 workers. Long-term deaths from thyroid cancer are estimated at 10,000. While this is a tragic accident, the collective death toll is extremely small compared to that of other sources of electricity. For example, the average fatalities per terawatt year are LPG 3,280, coal 342, hydroelectricity 883, and nuclear power 8. From this information, we can conclude that the danger of nuclear power is relevant, but extremely small compared to other energy sources. New technology and fail-safes make nuclear energy a reliable and highly safe source of electricity for the world. Nuclear energy is an extremely efficient energy source. Uranium fuel has an energy-to-weight ratio tens of thousands of times higher than coal. The mining and transportation is much cheaper than fossil fuel transport due to its compactedness. Many see nuclear power as 100% environmentally friendly. This unfortunately is not completely true. With all industrial processes, carbon is emitted in the refining and mining process. This is a very small amount compared to the emissions caused by fossil fuel energy. Considered the worst face of nuclear power is the radioactive waste produced from the power plant. This waste is highly radioactive and has a half-life of 240,000 years. The waste must be kept inside a radiation shield to prevent the escape of harmful radiation for this time. As of today, there is no perfect way to dispose of the waste, and much of it is in storage facilities. In terms of safety, this is the weakest link. If something happened to displace the nuclear waste, it could cause high amounts of radiation to leak into the environment. Many propositions have been made to safely dispose of this waste. Plans have been drawn to bury the waste deep underground away from fault lines and areas with earthquake risk. Some plans involve sending the waste into orbit away from the Earth. This is the most permanent solution, but it is also the most expensive and the highest risk. A main issue with nuclear power is that it sources its fuel from a non-renewable resource. The uranium fuel will run out at some point, just as fossil fuels will. As of now, the estimated world total of uranium in the Earth is 5.3 million tons. Just under 1/3 of uranium is situated within Australia. If current consumption is not changed, it is estimated that uranium will last for a further 300 years. Due to uranium's finite amount, other fuels are being researched as a viable replacement. So far, it appears that thorium is the key. Thorium is in much higher supply and is much safer. The waste produced from a thorium power plant would have a radioactive half-life of less than 100 years. In conclusion, I believe that nuclear energy is a very complicated process that should be respected. I believe that it is a much more reliable and more environmentally friendly alternative to all other forms of electricity production. The fact is that the continued use of vast amounts of fossil fuel could lead to catastrophic environmental and health problems. While this fact stands, there is a much higher potential, not chance, for a major accident to happen. There is no perfect solution to our electricity-hungry society, but I think that the continued use and innovation in the field